So we're going to take the derivative of our function here from first principles. So our equation for first principles is given by f prime of x is equal to the limit as h tends towards 0 of our function with an addition of h minus our original function divided by our h. Again, our function is not written as f of x, it is written as y is equal to a function of x. So we'll write this as dy dx is equal to the limit as h tends towards 0. So now we've got to put our value of f of x plus h as our function in here. So wherever there is an x, we put in an x plus h. So that gives us 3 minus 2 outside of x plus h. Now all of that is cubed. Now we add our minus in from our function, and then we add just our function value in. So that's our 3 minus 2x cubed all over h. And cubes are really fun, so we'll take the limit as h tends towards 0 of 3, and we'll write this as minus 2 outside of x plus h, and then we'll write it again, but this time we'll just add a square because we can solve that one fairly easily. Cubed all over h. Now this will give us the limit as h tends towards 0 of 3 minus, well, we'll have x squared plus 2xh plus h squared from this section, and then we have to multiply it by x plus h through our normal bracket multiplication. So I'll write that out as being 2 outside of x plus h, x squared plus 2xh plus h squared minus, don't forget the brackets, 3 minus 2x cubed, and all of that is over h. So, right, continuing on, we've got the limit as h tends towards 0 of 3 minus, now we've got x times 2, which is going to give us 2x cubed. We've got our 2xh times x times 2, so that's going to give us minus 4x squared h. Then we have our h squared times x times minus 2, which is going to give us minus 2xh squared. We'll have the same thing, but with the h's this time. So we'll have minus 2x squared h minus 4x h squared and minus 2h cubed. And we'll expand the second brackets this time, which is this point here, which is going to give us minus 3 minus 2 plus, x cubed. And all of this is over h. Now we can start with our simplification. So we have a 3 and a minus 3. We'll get rid of those. We have a plus 2x cubed and a minus 2x cubed, so we'll just get rid of those. And each one of these that remains has a value of h in them, so we can cancel it with the 1 down the bottom. So that one will disappear, that's gone, the square goes, that disappears, the square disappears here, and this changes to a 2. So now let's write all of this out. So we get the limit as h tends towards 0. And what we have a minus 4x squared. Then we have a minus 2x. Now, summarizing all of this, we have the limit as h tends towards 0. Now we have a minus 4x squared and a minus 2x squared. So minus 2 and minus 4 is going to give us minus 6, and the x squared remains. We have a minus 2xh and a minus 4xh, so we can put that in as minus 6xh. And we also have a minus 2h squared. Now we can just look at when the limit as h tends towards 0. So these parts here, the 6xh and the h squared, are just going to go to 0, as in they're not going to be relevant anymore. So this will be equal to minus 6x squared. So our derivative of y equals 3 minus 2x cubed is going to be equal to minus 6x squared.